In the previous video, in which we were working on our own custom function, we prompted the user for their name, and then we passed that name into a function where we simply took their name, added it to a nice message, returned it back out, and then we pop it up on the screen. Now, there's a lot of instructional stuff that we can pull out of this relatively simple function here. First thing I'd like to talk about as it relates to functions is how we passed this variable into here. There's two different ways that we can pass information into a function. One way of passing information into a function conceptually is sending a copy of it. So this is right now a variable, or it will be a variable that holds a name, like my name, Dagan. And this has a different name than this. And so how many copies of the word Dagan are there in the program? Well, in JavaScript, because we're using a simple string, when we pass a string to a function, it is always passed as a copy. So what's in here, even if it gets changed as a variable somewhere within this function, is not going to impact the thing that's on the outside. Now, in other languages and in other circumstances, you can pass things to a function by reference. And that means pass it by reference to a place in memory, meaning there's only one version in the computer's memory of maybe the person's name, but there might be a lot of different variable names that are pointing to it. So when you pass something by value, and if you were to change it, for example, then despite the fact that there might be lots of different variable names, since they're all pointing to the exact same spot in memory, changing that thing will change it for everything, for every single variable. So for us, whenever we use a function and we pass in a string or a number, those things always get passed by value. And by value, I mean we're making a copy of the variable. And so changing it doesn't change the outside variable. Now, in other cases, if we were using something such as an object, which is a topic for a future day, if we pass an object here, then we're actually not passing a copy of the object. When we pass an object to a function, we're actually going to be able to change the real thing because we're passing it by reference when we're sending in objects. So what we're doing today is not going to be consistent across all types of variables that we pass in. But for today, it's just a copy. Okay. Secondly, I want to talk about returning things from a function. So I created a separate variable here, and I don't have to create a separate variable. In fact, I could get rid of all of that stuff. I'll just hit Control X, delete it, and that would be fine as well. So I just created one big long string that I'm concatenating with this plus symbol, and I can just return that and it'll be just fine. And of course, I don't have to return anything at all. That's only if I want to have some variable out here waiting to receive the output of the function that I've created. Okay, let's talk about yet another idea here, and I'll go ahead and hit undo a couple times because I liked how that looked. Let's talk about scope of variables. Now, what does scope mean? It means where can we see, or where can a computer see and understand what a variable contains? Let's just say that your name is Dave, and when you're at your house, if somebody calls out Dave, everybody knows who we're talking about. But if you go into a big, huge crowd and somebody yells out Dave, well, there's some ambiguity there. So within the scope of a home, you probably know who a variable, like your name, refers to. But when we get into the wide world, scope can be a little bit more confusing. Well, this is kind of like the outside world right here. And this is kind of like the inside of your house. This we would consider to be global scope for your program. These are variables that are available everywhere, but there could be potentially thousands of them created. And this is considered to be local scope whenever we're in a function or we're within curly braces. That means that anything that we declare within those curly braces is restricted in terms of referring to it just within here. So let's go ahead and demonstrate how we can, how the computer sees things differently depending on where they're declared. So I'm going to come and write down here. Well, let's see. Let's say alert, and then I'm going to say inside employee name. Okay, so we know that this name only, because of these highlights, right? It only exists within this function. So let's see what happens. By the time we get through here, it's already been used, and then it's returned back some message, that function. So does this variable still exist anymore? Let's find out. So I come back and I type in my name. Ooh, what's going on? Well, I clearly have an error message. So let's see if we can find what the error is. It says S inside employee name is not defined. So because this is completely empty, our program stopped executing and it's not working. All right, fair enough. What if I got rid of that? And what if I came over into here and I said, instead of referencing this, can I reference this thing that's out here? You'd think that since it was created, let's go ahead and try and copy that. You'd think that since this variable was created outside here, and then we go into some function somewhere that looks nice and isolated, that it wouldn't know anything about this variable. But let's see what happens. So I'm going to come over here. I'm going to type in the name. And it does the name. And then it goes on and it continues the program. So what is the lesson that we've learned here? Well, what we see is that outside of functions, we can't reference the variables that were used in there either before or after the fact. Once the function is over, that variable disappears from the computer's memory. But strangely, when we have a variable that exists outside of a function, it can be referenced in the function just as if it had been passed to it like a parameter. So that might raise a question. Why, if we can reference a variable inside of a function that was declared outside of a function, then why do we pass parameters there at all? Well, several thoughts here. We like to use functions as little black boxes where we send in some information, we modify just what was sent into it, and we send it back out again. If we start modifying global variables from inside our function, then we might get some really strange results, and so that would be a bad thing. So philosophically, we would like to just only work with the things that we've passed in. And another issue is we might have thousands and thousands and thousands of outside variables that could potentially be mentioned within a function. So we don't want to accidentally overwrite those. And one way that we can do that is within our functions, we just declare a new variable name and start working with it. Now, what happens if we declare a variable name that already exists on the outside? Well, JavaScript is smart enough to know that if you use the same name in here that's been used outside, as long as you declare it with the let command, it's going to be okay. And it's going to know that you're talking about their internal one, and it's not going to overwrite the external one. When would we maybe want to use some global variable and reference it within a function? Well, an instance where we might want to do something like that is if we have maybe a global constant. So for example, maybe you're using pi 3.14197 or something like that. You declare it up at the top of your program, and maybe you use it in all kinds of places. Or maybe you have a connection to a database that you set up in a variable at the top of the screen, top of your code. And so maybe you want to use that all the time because all of your functions are writing to the database, but they're doing it in different contexts. So there are some cases where it would be desirable to access a global variable, but generally speaking, you're going to be safest if you avoid that.